right. So today, kind of set up an interesting conversation with some of our quantum experts on campus. So I'm Jason Jenkins. I'm an assistant professor in the Beacom College, and I teach INFA 723. So it kind of leads me into um, a bit of exploration of quantum computing, but not to where I would really say I'm any kind of expert on it. And then so that's where I kind of turn to some of the folks that are teaching those classes at DSU, and some of them are very new, and so we'll have some things to say about that too. But um, if you could just go ahead and introduce yourself quick before we get into the questions. Let's start with Peng.
Oh, okay. All right. So I'm Peng Guo, and I'm the only physics faculty at DSU and from the College of Art and Science. So my background is the computational and the theoretical physics, and so I joined the DSU at the 2023. So this is my third year at the DSU.
I'm Mariam Gado. I'm an assistant professor at Beacom College. I have a master's and a PhD degree in quantum computing. For my master's degree, it's about quantum circuit optimization, and for the PhD, it's about quantum cryptography. And I graduated in July and joined the DSU in July, and this is my first semester teaching.
Awesome. Well, glad to have you. It's been I'm glad you can make time for this as well. So I do kind of have some prepared questions. We'll kind of walk through all that, and then if anything comes up as we go, we can certainly add that in. So my first question is for Ping. How long have you been teaching, and what are some of your primary areas of interest?
So I started my teaching career in 2015 and at the California State University in Bakersfield. And so basically at the Cal State, I was primarily teaching on physics subject and so both lower division and upper division, all the physics courses and plus astronomy and educational courses. And so my interest, I don't have a specific interest, and I actually have a quite a very wide uh, interest toward all different subject and the computing and the quantum and the physics and as far as is fascinating and I'm always very interested and intrigued by the science. So I'm a big fan of the science.
All right. Thanks for sharing that. So, Dr. Gado, could you tell me, we mentioned that you really recently completed your PhD. Can you talk a little bit about that research? I mean, especially it's of interest because you just completed it, and like how it connected to quantum.
So my research area for the PhD is really interesting. So the funding itself was about securing the smart grids. So I needed to find a collaboration between cryptography and quantum computing. So then when I did my research, I found the quantum cryptography area. There's like quantum key distribution, and you can secure the keys using quantum key distribution, and it's unconditionally secure. But there is a newer science that's called semi-quantum key distribution, where two parties, both of them does not have to be quantum. One has to be quantum and the other one can be classical. And that's, of course, is going to reduce the cost of upgrading the whole system to quantum servers. So my main research area was selecting a minimal number of quantum computers to be upgraded, for the nodes to be upgraded to quantum computers, and the other nodes are going to be classical.
Awesome. Yeah, well, thanks for sharing about that, and I'm sure those that are interested to learn more can probably find some
Yeah,
more
of
about
course
that online.
they can reach out to me, or they can search my Google Scholar. They can find some IEEE papers I have published, and also I applied that research work on IEEE bus systems, so it's applicable.
Yeah, that's great. So for Ping, um, so if I'm remembering the history right at DSU, you were the first person really to teach a quantum computing course or something related to that. Maybe it was more the physics side, but just, I don't know, can you walk us through that a little bit? Like you were kind of leading an emerging area. That must have been kind of exciting.
DSU offer two different type of the quantum computing program. One is a graduate quantum computing certificate. So that is a 4 course certificate. So the first two courses are the quantum computing fundamental and the quantum computing programming. And so those are the ABC of the more advanced the application, and then the another two courses are the more advanced application in the quantum the post quantum cryptography, and so Dr. Gado was is teaching the second and the third course. So sorry, the last two. So I was a teach. So the quantum graduate certificate was offered a year and a half ago. So I was the person teaching the first two courses, and also for this semester. And so it's basically rotating. And for this semester, and we start offering the quantum computing fundamental. So those two courses are basically covering the fundamental of the how do you take advantage of the quantum information and then trying to do the useful thing, for example, the computing or the communication and whatsoever. So really just the fundamental of the foundation of everything. And the second course of the programming is really just learning about the using the quantum computing program, for example, the Qiskit, and to code up some algorithm and the current the quantum well-known quantum algorithm, and the learning about the how to use the quantum computer as a tool. And so those are uh, the the graduate certificate. And then for this semester, and we also started offering the quantum computing minor and the intro to quantum computing minor to the undergraduate students. So this is the first time we offering the minor to the minor course of the quantum computing. And so basically the first course is having a relatively low bar, and so basically really just to try to get people in the field and then get excited about things. So for this semester, what we are really covering is also kind of the setting up the foundation about the ABC of the quantum computing, and learn the very basic of the programming skill. So that's what we are doing. And Dr. Guido probably can tell you more about what she's teaching for this semester.
Yeah. Well, we'll save that for the end, but I do want to hear more
Yeah.
about it. Um, Dr. Gado, so you attended Quantum Summer School at Oak Ridge National Lab in 2024. Can you tell us just about that experience and what you learned and how it helped you along your journey so far?
So there was a quantum summer school in Oak Ridge Lab. It was very selective. It selected under 100 person all around the world. And then we had an intensive quantum computing advanced level courses that we used to take every day for 2 weeks. And we were not only taking like courses in quantum computing, it also included material science and hands-on experiences. And then 25 students, and I was one of among them, were selected in order to present their research work in a poster session inside this school. And then a lot of people were able to come from all over the world. I really liked it. I made a lot of connections in this school and possible research collaborations.
Yeah, that sounds like a really unique and interesting experience. So, was the poster that you presented, was it connected to your PhD or was it kind of separate?
No, it was my first paper ever. Like I published this paper in a conference, but I also used the same work in order to conduct that in the poster session, since it doesn't have to be unique in the poster session. So I was able to conduct my research area, and I was able to connect with was one of the people there who also was interested in the same research area. Because of course, quantum computing has a lot of different branches. And for me, I work mainly in networks and quantum cryptography. So I was able to connect with people with similar research interests.
Well, that's great. But, thanks for describing that for us. So for Peng, my next question is, what do you feel like are some crucial skills for someone who wants to get more into quantum computing?
It depends whether the student is taking the graduate level or the undergraduate level. And for the undergraduate level, so we intended trying to lower the bar, and for the entry at the for the student actually can grasp the basic idea. And so, but hopefully, I still hope, before the student can take the class, and so they at least have a certain knowledge about the matrix manipulation, and so the know a little bit about linear algebra and the complex number and the things like that. So because later on, so more or less, and so they have to get used to the those type of the mathematics. So the more or less they have to the play a little bit about the math. And so this is for and for the programming part. And so I think the DSU student more or less already have a certain skill of the programming. So majority of them, before they take class, have a more or less certain amount of the Python programming and the experience. So that make my life easier. For the graduate level, and so I think it's a kind of the similar thing. And so I think the kind of the prereq is definitely the linear algebra and the complex analysis. So that's something in order to analyzing the quantum algorithm. So that's something they must have, and otherwise, the life is going to be a little bit tough. So,
Yeah. Thanks for explaining that for us. I know it always, like you said, it varies on depending on what classes they're interested in or what parts of the field. So Dr. Gado, could you tell us, and this is a question I'm very interested in too. It's one of the reasons really why I included in the cryptography INFA 723 class, but why do you think students or just people in general should be interested in quantum computing if they also have an interest in cryptography and cybersecurity?
So, as we can see now, AI, for example, is very common and a lot of people are using it. And I predict that the quantum is going to be the next technology to be also spread worldwide. So, if you are interested, like as a student, in order to be a pioneer in this new field, then I suggest that you reach out to one of us, like either me or Dr. Peng, in order to talk more about how you can do that. And since you are a graduate student, you can. I also advise you to take the quantum certificate 100% because I'm teaching like the graduate level classes, like the second two classes. One of them is quantum resilient cryptography. This class I'm teaching that for this semester, we are taking like a more in-depth quantum computing about like the Grover's algorithm, the Shor's algorithm. Then we talk about quantum key distribution and different kind of quantum key distribution and semi-quantum key distribution. And also it's a research-based course. So you will be required to create a paper by the end of the semester. So it's a really fun experience and you will learn a lot from that.
Yeah, no, I appreciate that. Um, I find it I find that students are quite interested in like the intersection of quantum computing and cryptography. It's captured a lot of attention and rightfully so. It certainly takes up a decent chunk of the cryptography literature. So I definitely understand how that comes to be. I know one of the notes I kind of had for myself just to make sure to address, when I teach the course 723, there's a few different angles I'm approaching it from. One is, really I'm a software developer by trade. If you look at my time immediately up to teaching, so I want people to think about, how they can secure the systems they're creating and maintaining. But I also am worried about kind of the information assurance angle for cybersecurity and cyber defense. So why care about some of these things? Like, if you're more of a ISO or a compliance officer or someone that's a little more in that sort of realm. Um, and then I've, at some point learned about, the concept of harvest now, decrypt later as kind of a security threat type. And so I find that to be very fascinating that the work is really not as simple as just making better algorithms. It's being concerned with how things are today, because someone could easily just take currently secure data stores and then just decrypt them later. Let's just say it's 10 years down the road, and some data won't matter in 10 years, but some will. So uh, it- you know, the hackers are busy out there, and that's another angle for them to pursue. Um, so my next question is for Peng. So, and some of these things I brought up, like this question, and the one about the Oak Ridge National Lab, you can definitely look those up if you look up our professors and just online. But Peng was recently chosen to receive an NSF award for his work in quantum. And so I was just wondering if you could talk a little bit about that. Like, what are your goals for that? What do you want to accomplish with that? I don't know if it's something that you'll eventually need to hire any student help or if it's more self-contained, but I just kind of wanted you to have a chance to talk about that. And of course, congrats on even getting it in the first place. That's really cool. So,
Thank you. Thank you. So basically, so the project I proposed was trying to study the nuclear reaction, and so using the quantum computing and simulating the nuclear reaction. So that part is really the long way to go, and is really just the long plan. And so at the current the short plan is trying to developing the algorithm and the methodology because the quantum computing is still relatively new, and how you translate everything and onto something quantum computer can actually directly implement. And so is something we have to working out. And so it's not really straightforward. So basically the goal is really just doing the physics simulation and by using the quantum computer. And so I think maybe I should mention, so the one of the reason we want to use the quantum computer, or the people proposing using the quantum computer was trying to simulating the physical world. And so I talked a lot and in number of the presentation. So I actually some student probably already heard something I mentioned. So basically, idea is the entire world is a quantum if you if you dig very deep into at the atomic level. And then so basically when you are dealing with the physics, the deep level physics, and also the chemistry, and you have to use the quantum mechanics, the quantum theory to describing what's really happening over there. And so the before the quantum computer, and the people have to find a way to simulating the quantum system. And the way of doing that is you have to translate the quantum problem into a statistical problem, which can be handled by the classical computer. And so there are a huge number of the problem and the hurdles to that approach. And although people did already have made a lot of progress, and so the number of years ago, the Feynman proposed we should actually invent something called a quantum computer, so which is in nature is a quantum itself, and then you can use a quantum object to simulate in the quantum world. So that was the original goal of the inventing the quantum computer. And so basically, so now we already really having the real world quantum computer, and so the people, a huge number of the people from all different fields, and trying to take advantage of the hardware, and then trying to use that to simulating the quantum world or some other things, for example, the drug invention or whatsoever. So that was the subject, the project, and so I was proposing and on the grant, and so. So that's pretty much, the kind of the very short summary about the grant things. And for the student part, and yes, and I definitely can use some help, and hopefully, so the grant can bring some opportunity not only to the faculty and also for the student as well. And because we are also trying to building collaboration and between the DSU and some other institution. So those institutions could having the create some extra opportunity and for the student to get involved in the quantum computing science. So, yep.
Awesome. Thanks for running that, going over that with me and with us. So Dr. Gado, so this one's a little bit open-ended and it's a little future planning, but so how do you mentioned AI once before, how do you feel AI will affect quantum computing?
So I think they can go hand in hand, and both of them can accelerate each other. So, for example, I used genetic algorithms in one of my papers or multiple of my papers, and that helped me in order to implement or use quantum cryptography in the power systems. But I also discovered that there's something called quantum genetic algorithms. So anything that's classical, you almost can find the quantum part of it. So for the collaboration between quantum and AI, it's a very hot topic right now. And for example, Google had some kind of grant before about the Google AI, and using quantum computing and AI in the acceleration of the research. So I think it's going to be a very interesting research area. And
Yeah.
especially that also I have two of my undergraduate students. We also won a local grant, which is inside the DSU, the SRI. So now we are working on quantum machine learning. So it's a branch of AI, of course.
Yeah. It's exciting to see what they can do together. So I just wanted to kind of mention this. So we had a speaker here on campus last year, and they were from the quantum part of IBM, and like they were kind of showing like a timeline on the screen, and it kind of sounded like, as much as we talk about quantum concerns in cybersecurity, that probably wouldn't be like any massive developments for a few years. They're still working. It seemed to be looking down the road a bit. Something, and the current NIST cryptography like standards kind of go out to 2030. So it seems like there's some harmony in those timelines, but I do kind of wonder if, AI will end up maybe moving some of those around a little bit or moving them up, but who knows? A lot has happened in the last, 3 years or so. So kind of hard to predict out that far on much of anything anymore. So my next question is for Peng, and we're going into kind of the open-ended world a little bit again, but I think everybody is curious about this even still. What hopes and fears do you have for quantum computing and like how it could affect society?
I don't have very much of the fear because I'm relatively optimistic person, and I think all those new technology are very useful. And so, although the quantum computers are the hardware part, it may be are not quite ready yet, and so it will take another many years and to develop and mature. And but even now, even at this stage, and so with some the people call that the fault tolerant quantum computers, and that means very noisy computers. And the people already did a lot of very fascinating things already. And so I think the people are not gonna wait for things, and so a lot of smart people will just jump in even in the early age, and then so they will, the early age means is not mature, means a huge amount of opportunity for people. And so if you are waiting up to the last minute, and so I don't think there much of the cake and for people left over to eat. And so I think so for me, and I like the new technology, and the quantum computer definitely is the one of the emerging and the very promising machine, and the people are trying to accomplish and build. And so that's a great human, the human achievement. And so I think the quantum computer definitely will be there. So I don't believe quantum computer is going to completely replace a classical computer and in terms of the cost and efficiency. And but so it will be there for very long run. And so it may be, the eventually, and so in what form, and in terms of the application, maybe it's not exactly what we're expecting, but so this is the place all the innovation and the new idea is supposed to kick in. And so I'm very optimistic. I think the human being are really fascinating creatures. So the smart people are just constantly coming up and came up with a great idea to utilizing those emerging technology. So that's my take.
Awesome. Appreciate that. So the next part I'm going to just ask of both of you. I think we'll actually reverse here and go into what advice would you give students interested in quantum or other emerging fields? And we'll start with Peng.
I think if you find it interesting and go for it. And so I think especially for those emerging technology field, and so although there are certain bubbles, and but it's a still, so there are bubbles means so the people are interested, and so there is it may be not completely fulfill all the promising people are hoping for, but so if it's good, eventually it will stay. And so and for the young generation students, and I think it's a great time to jumping into the new field, to learn something new, and just widen your the knowledge base, and then the start creating the new idea. So I think the American is the land of opportunity, and so I hope I hope to see the most new student, new generation can come up the better idea and take advantage of all those very fascinating technology and around. Especially this is a really great area, and so you really have you have the hardware and have the opportunity, and so this is a really great area and for the young people, and so try not to miss these good opportunities. Yep.
Yeah, I really appreciate the optimism you mentioned earlier. That's really good. Dr. Gado, you want to chime in on that one as well?
Uh, so yeah, like Dr. Peng said, like if you are interested, just go for it. You can find resources here in VSU through the quantum certificate. Then since you already are a graduate student, or you can reach to one of us and discuss your research idea if you want. And there's a lot of online resources that are for free, like IBM or Google. You can see how the programming languages for quantum computing that work. So there are a lot of opportunities and stuff that you can do in order to go into quantum computing.
Yeah, and I was going to say, I tell my students about this all the time, but if we have any undergrad students that end up seeing this, We do also have, Beetle Scholar, which is scholar.dsu.edu, and we don't have like a lot of quantum publications on there, but there's definitely some. I noticed some from Peng here, so that's pretty cool. Probably
Thank
quite
you.
a few of them ultimately, but some stuff to check out there if you wanted to narrow down to that resource. Um, so I really appreciate all the insight and the answers to the questions. I was going to spend a little more time talking about the classes because you did, we kind of covered it as we were going, but I was going to actually see if I could share this. And let me, because I have the catalog for the certificate and
Mm.
at least what I found for undergraduate classes as well. So can you see that?
Yeah. Yeah.
Yes.
Yeah. So these are those four classes you were talking about.
Oh, so this
And
is for a graduate certificate.
yeah,
Okay.
so you can kind of expand those. But again, all that
Mm.
stuff is catalog.dsu.edu.
Right.
Remind me again, which ones of these are coming up in the next, like, calendar year, or I should say the next
So
3 semesters.
So I think the full course is on the rotation of the
Oh, yeah.
2 year rotation. So is that uh, Dr. Guido, is that on the 2 year rotation? Okay. So
I think so,
okay,
yeah.
right. So the last year, the first two was offered, and the first two were the quantum computing fundamental and the quantum programming. So and then this year is what offered is 767 and the 784, and then so these four. So actually, we're started offer the rotating again, and so this semester and we started the quantum computing fundamental again. So basically, I think you can call that a 2 year rotation.
Mhm.
It's not
Yes.
exactly, it's actually overlapping. So there is the
Yes.
overlapping.
Yeah.
Mhm.
Yeah, that's perfect. 'Cause I just would encourage anybody watching that has an interest to look up our catalog and just see what's out there if you happen to have any electives or just want to do the certificate. And then we've got a few here that are at the undergrad level, one in math, one in physics, and then more of a introductory. I would assume this one has some programming in it too, right? Um,
Right. So the first half of the semester was really just the fundamental ABC of the how the quantum computing the quantum computer works, and then how do you operating the gate, and how do you measure things, and then the second half of the semester is basically just learning about the programming.
um, Anything else you wanted to add to that, Dr. Gado?
No, for me, like I think Dr. Peng already covered every point, so
Yeah, and like I said, I realize too that this is all pretty new, actually. So um, it's not, we're kind of still working through the rotation, but it's exciting to have multiple faculty that are pretty interested in this area, and I'm sure we'll have more with time. But yeah, I don't know. I really appreciate you taking the time to do this, and I can't wait to share it with the students. And um, I'd encourage you to do the same. And
yeah,
um,
thank you. And I also want to add one thing about the courses for the quantum certificate.
yeah,
Or I'm developing that from scratch currently, and I'm trying to integrate as much like new technology and research into the courses. So it's unique anyways, like the quantum resilient cryptography or the new course. Both of them are very new, and I'm trying to use the newest technology so that you will be updated with the newest technology that we have about quantum cryptography.
yeah, that sounds great. Um, well, like I said, thanks again for everything. And I'll make sure that at least I'll share this to you when we're done. Thanks
Thank
for
you.
anyone
Thank you
watching
for
and for
having
your
me.
help.